Huh? Huh? So this very important development, you must be thinking, are we replacing humans? No, we are not replacing humans. We are augmenting them. That is the idea, right? So going back to going to the next slide, I have another important a video that shows that how another intelligent robot, which is equipped with reinforcement learning, is able to go inside the farm and it is able to identify ripe fruits and inspect their health, right? So you can see that this is amazing. The not only that, it is able to understand the environment and can act accordingly. As you can see, that is moving out. So without going into details, now I go to the next slide because so we can see that artificial intelligence is actually making machines able to perform tasks that normally humans do. But in our case, we expect this machines to develop to do tasks which are done in a more efficient way than humans, right? For example, humans, laborers, they will be required to crawl around the entire trees to understand the each and every fruit, whereas we expect that this simple dog was able to identify ripe fruits, healthy fruits, rotten fruits, different types of fruits. So over time, if I look at the evolution of AI, computing, we started with computing, that it was evolved into data analytics, and then to data driven insight to learning based intelligence, right? So data was is a primary important element here. We started with rule based intelligence, symbolic logic based intelligence, then data analytics. Then from data analytics, the humans were able to identify insights. Like, for example, over the last 4 years, what was the rainfall? How this was able to, this was affecting the crop health and crop yield. Accordingly, humans were doing identifying patterns and insights from data analytics. Now, in artificial intelligence, what is happening is we are learning from data. I mean, your algorithm is learning from data and is able to make decisions. That is the only difference between data analytics and AI. So the term AI was taking shape in 1940s, 50s, where people were thinking of creating an artificial brain. And one of the important contribution, we must give credit to Norbert Wiener, who talked about cybernetics and early neural networks, and then Turing test, which defined when we can say a machine is intelligent. And it was the term was coined in 1956 Dartmouth Mouth Conference, when many 6, 7 different scientists from different fields, they collaborated, and John McCarthy was one of the pioneering scientists, and they defined the term AI. So AI system, what is AI system? Consists of an agent. This agent can be like any agent. It can be a drone, it can be a software system, or it can be your edge device, any agent which has some abilities. Abilities can be, it can perceive, it can process, that can be the abilities. It has some goals and preferences, and it is equipped with some prior knowledge, like knowledge of the environment or the knowledge of what has happened in the past. All these prior knowledge is there, and it senses the environment. Like you are sitting here sensing an environment. Similarly, it senses the environment, and based on the environment, it takes some actions, and and of course it uses past experience, so it uses some takes some actions, and that action like is basically as an interactive thing that happens, So it consists of an agent and an environment. Agent can be hardware, software, it can gather information. Agents can be of several types, like reflex agent. For given a scene, scenario, it takes an action without taking care of what has happened in the past. Or it can be goal based, like a robot has to reach from this place to that place, can be role based. It can be utility based also, and mostly in the recent year, learning agents are there. So today, if you see, it's becoming a ubiquitous entity in uh, everyday life. Think of your mobile, think of anything like your railway reservation system, airline reservation system, or your agriculture system. So they're already operating, AI is already operating behind the scene, right? Uh, so starting with 1950, uh, artificial intelligence to machine learning, that was, so what happened in 1950s when AI was evolved, people thought that it will be able to speak, it will be able to understand, perceive like humans do, but we were not able to do with those symbolic logic and uh, knowledge based systems or heuristic search. They were not helping us, and as a result there was a winter means funding and interest of people, interest of companies went down. And then the concept of machine learning came, where AI systems that learn from historical data. But then that was also not sufficient, because there were two important things like perception, uh, vision, and speech. These were two things like natural language processing. These were two things which were not getting into like the uh, kind of performance that we expected, was missing. And therefore, uh, deep learning, idea of deep learning came. What is deep learning? Nothing but like our neural network is having a very deep layers. So how these deep layers process information and act and reflect, that was something it was not less, was less understood, and therefore we were not able to like do good with neural networks. But in 2006 to 2012 there were several developments that helped us, and also 2015, that helped us understand that how neural networks pass on the information and take action or decision, right? We were better able to understand. I would not say that we have not yet understood how neural networks work, but we were able to better understand. Then came the field of generative AI, where they are now able to generate or synthesize new data, new environment, new things. So generative AI is helping in improving the task of deep learning models, whether it is what kind of decision you have to make, regression, classification. So generative AI is helping a lot. So generative AI is again a kind of AI that can create new context, like content like data, text. You all know that. So I will not go into detail. I will not go into details there. So what are primary AI tasks? I'm going little fast because we have killed our time. I'm sorry. So mostly you will find that AI tasks are like perception. Perception kya hai? Plant disease detection through vision AI. That is one example. Perception can be understanding the scene. Perception can be autonomous driving. But this is from agriculture domain, that we understand and detect what are plant diseases. Suppose your drone is moving around, hovering, and it is able to identify spots where there is malnutrition to plants and all that. Reasoning, uh, so optimal irrigation scheduling. Suppose soil moisture is understood, what it is the soil moisture. Accordingly, it will be creating the schedule. Learning by looking at the current temporal data, like from last 5 months or last 3 months, depending on the type of crop, it will be able to identify, understand that what will be the yield, right? So temporal data can help it learn that. Similarly, action, that is like spraying, herbicide spraying, using real-time data analytics. If you see in this part, there is some herbicide required, then it will spray. Otherwise, on healthy plants, it will not be doing that. And similarly, interaction. What is interaction? For entire farm management, you have base stations, you have drones, you have entire IoT network. The AI behind the scene will be managing this entire. So these are AI tasks. I have made these slides assuming that many of you are from agriculture domain. So please bear with me. If you are from computer science or engineering domain, and you already know all these things. So type of problems for AI solutions. What are the problems? Classification is one very simple problem, right? What is classification? You are having an input that is a plant image or a soil card, like soil parameters. These are input, and I want to map it to an output, like what kind of soil is this, whether the soil is healthy or not, or I want to now map this to image to a disease plant or a healthy plant, right? So what I'm doing is that I'm sending the input to the output, and these categories are only finite in number. So it is a discrete function. As a computer scientist, I will call it a discrete function mapping a continuous space to a discrete space, right? uh, Regression. Regression is basically predicting a continuous numeric value, like temperature is a continuous numeric value, right? Like humidity, you can say that is a, it can change over time. So prediction of crop yield can be a value. It is a value that is a continuous value. And weather, it's a very difficult to predict. NDVI data, we will see what is NDVI data. It is related with satellite, where it is difficult to manage the entire data of satellite to be converted into some numerical values, or estimating soil pH value using satellite images. So we will, over a period of time in this course, you will learn more about this. Similarly, clustering. What is clustering? When we have uh, idea about some groups, like objects are in different groups, and you want to group similar objects in the same group, right? Like similar soil profiles, satellite images by their vegetation pattern. I want to cluster them. Other important aspects where AI can be involved is, say, anomaly detection. Crop is healthy everywhere through satellite. Somewhere you see anomaly, right? Anomaly detection. Generating synthetic data. Why we need synthetic data? Because for many fields, so data is not available. If you want to train the AI system, you need data. Current AI system require. So how do we take care of this? By generating synthetic data, and sometimes data is given, but you don't have labels. So synthetic data can be helpful. Then you can have decision optimization. So these are some of the most frequently used AI tasks associated with problems from different domains, not only in agriculture. So how do we build AI solution? Is this clear to everyone what we are doing? So first process is data collection, because the modern AI is dependent on data. Earlier, what we call as a good old fashioned AI was based on symbolic logic, was based on rules and heuristic search, not much dependent on data. But the AI model is dependent on data. Why? Because brain is every single second is receiving data and is processing data, accumulating what is important, and keeping in the secondary storage memory of brain, right? Primary calculations are done, they are done, and everything is then finished, right? So that is what is data. Every single second, humans are receiving data. So data collection is important. So when I am collecting data for training a neural network or training a machine learning or AI solution, AI model, I need to pre-process data, which is automatically done by humans, right? By looking at, say, huge amount of vegetation, an expert can immediately identify that here is the weed, whereas AI solutions need to be trained that this is the weed, right? That is the difference. Okay, so data pre-processing is required. Designing a, then you actually require, okay, we have created data, we have data pre-processed, what kind of model? What is the problem that we are approaching? Problem can be farm management. It is a different problem. Problem can be pest or disease detection. That is a different problem. So for each problem, you need a different model, right? For each different problem, you need different experts. Like for farm management, farmers are not important. For farm management, different other people may be required. Like farmer's son, who is more into marketing and dealing with vendors and all that. Whereas farmer is more expert, having expertise in processing the field at the field. So you need to have a specific model to train, and then you have to also define a training strategy. Like doctors are trained differently, engineers are trained differently, mathematicians are trained differently, right? And farmer is trained differently, scientist is trained differently. So you need a training strategy. And then once we are done with this, you train a model. Just like students are trained in two different ways. Eklavya, who did not have any guru, and Arjun, who had the privilege of having a guru. So teaching with a guru, training, you get trained using having a guru or no guru. Then evaluation. So once you train the model, you know that everybody requires evaluation so that you are ready for facing the real world, right? So whether it is students who pass the test and then go to a real world scenario, they may miserably fail, or they may pass, depending on the kind of training that have been given to them. Then once evaluation, they pass the evaluation, they're deployed, and then comes the real testing of the model, where model is actually doing or not. For agriculture, my dear friends, we have done many times using drones, using different scenarios. But let me tell you, the kind of 99% accuracy, 99 precision, drops down to 50, 40. That is happening. And that is where we seek your support to let our systems improve. Your contribution is very important in this. So let us begin with data collection. And data collection is, first, you have to identify the purpose for which data is being collected. So data can be collected for disease and pest detection. Data can be for soil health. Data can be for finding out what is the crop yield, right? So हर के लिए you need a different data. Now, knowing the goal helps decide how to collect data. Sometimes students come to us, ma'am, we have created 200 samples, but the way they have collected samples is of no use, because the features that are required to solve a specific problem that have not been truly understood by students. So, for example, for the task, suppose it is classification now. For crop disease detection, you require labeled plant images or leaf images. Like experts should be able to, like, we need the help of expert to label it so that it is able to classify, so that we are able to tell the model that this is the healthy plant, this is a diseased plant. For regression, I hope regression, you know that we are mapping the input to a continuous variable, right? That is regression. Where what we do, like predict yield. Yield can be, say, 2 quintal, 4 quintal in a small holding, farmer, small holding. The yield can be there. Where the data can be, for example, soil, weather data, fertilizer data, satellite image, depending on how we are going to solve the problem. So we have been solving, like Akshay and one of his students who is also working with me, we're working on satellite and remote sensing data to predict yield. Then clustering. So clustering can be, we are grouping similar farm types so that we can provide the similar solution to the farm, right? So as you can see that uh, clustering can help us where we do not need labeled data. So even if there are no experts looking at the patterns, the AI model will be clustering them together, right? So that we know what kind of farm it is, and then we can seek help of expert to understand better for each cluster rather than for each image or for each data sample. We expect the experts availability, that if that is not available, then we cluster them, and then we take an average sample, random sample from here, from each cluster, from each group, and we will seek help of the experts. Then it is also used in control systems. For example, for a smart irrigation, you need to have AI based control systems, which requires real time sensor data, water flow. So this is how data collection is done. Is that okay? We will be providing you all the slides soon. Uh, Now, data sources. What would be the data sources for agriculture applications? Can anyone tell? Data sources. From where you will be collecting data. What's your good name? So he suggested very important thing which we missed actually, that we will be doing in some today's session. Introducing each other, right? What's the good name, ma'am? Huh? Gina. So can you please tell what kind of like data sources are there for agriculture? Please, you can be seated there. Mm, mm, mm. So where from you are collecting the data? What detection? Mhm, mhm. So camera, sensor is camera, optical sensor, right? Yeah, from the field. Ah, mhm. So these sensors are measuring the data. They're based on some like mathematical formula or physical properties that are captured by sensors, and then you collect data. That is the real data, right? So you have sensors of different type, right? Okay. So in field surveys, data source can be field surveys like manual or mobile based data collection, as you said. Then you have sensors and IoT devices where continuous data capture in time steps, soil moisture, temperature, humidity. All this is through sensors. Then you have remote sensing data also. Sometimes you know that remote sensing data is important. For example, let us take this Kharif season. In Kharif season, what happens that farmers are unable to go to the fields because of lot of water loggage. Something is there. They are not able to go to fields to inspect the entire farm, right? Even if it is a small farm. So in that case, remote sensing data can be helpful, can be through drone or through satellite. Then we also have weather stations. Climate and micro weather data is there. Then sometimes farm equipments, that tractors, harvesters, irrigation controller, like the one Professor Hartendu Singh sir, our director sir, was telling about, complete like automation of machineries from where you can collect data. And then we have market and government sources about prices, demand, logistics. Then we have on logistics, our Dr. Sunil Agrawal is working on logistics supply chain management. So they get data from market and from government sources to analyze the data, right? Then we have open source data sets. These are mostly repositories made by researchers for researchers. So that helps in primarily making AI model. But as I told you that when we go to field, these open source data set models trained on them do not do very well on this. So generalization of the model to unseen data is something of great importance and current research relevance. If you have data set, one data set on which you have trained the model, test it on another data set. You will see that it miserably fails. If your model is able to do well, then you are lucky, right? Then data cleaning is required. Like you remove errors. Sometimes blurred images, sensors have reported nothing. So zero values, null values. Then sometimes we have duplicate data. So when we do through drones, lot of the data is redundant. Like drone is moving, so you have very small changes in one frame, video frame, and another video frame. It's of no use. So we remove errors, duplicates, and outliers. Then we have to combine sometimes multiple data sources, like she was telling that they use sensors, they use images. So multimodal data. Our brain is so good in listening to voice, watching, and then sensing, but that we have like multi sensors, right? You have you have like different type of sensors, and you are able to process together. My dear friends, this is the current future area of research, where multimodal data, how to process that. None of the neural networks that have been trained, that have been evolved over a period of time, are able to do it so efficient, like the one the human brain does. So multimodal data integration and then processing is something of great importance. Data transformation. Why we need to transform data? Sometimes you need to see, computers will accept everything in digital format, right? Zeros, ones, numerical values. Data can be voice, data can be some sensor data, image data. We have to convert this into a specific format so that it can learn that, it can understand that. Normalization. See, suppose your image is having, say, 256 cross 256 pixels. So huge size, 2 to the power 8, 2 to the power 8. And your sensor data will be only 15 numerical values. So this image data will dominate the sensor data, whereas sensor data is equally important. So we are actually, when we will be processing together by this neural network, that will be dominating. So that is the reason we need to normalize, and uh, sometimes you need to do embedding also. Uh, Embedding means we are like words are then transformed to digits, right? Then we select only relevant features of data. So we remove unnecessary or redundant data, because from the data, see, if you have an image, in that image, lot of things are there. You are looking for the face of your friend only, right? So you identify your friend from the entire picture of, say, 40 people. Tomorrow when you go, you will remember that yes, Renu was there, who was one of the members. So that means you are actually looking at only relevant portion. So uh, relevant features are important. We remove unnecessary. This is known as a feature extraction or feature selection method. Then we, if experts are available, then we will be requiring experts annotation, like pest, what kind of pest, what kind of disease, what kind of crop, what is the crop health condition. Uh, then for training, see what happens when I'm asking, like when I'm training to our students, I tell them some numerical problems, right? We do some numerical practices with numerical problems, some lab experiments. But in exam, I may be asking related, very similar, but not the same problems that we did in class, right? So training on a different data samples and testing on different data samples. So that is why data needs to be split into subsets. Is that okay? I hope I'm not going fast. So I'm just telling you the entire AI data, like AI pipeline. Uh, and then when you do not have enough data to train the AI model, then you need to augment it. There comes the importance of generative AI, right? In the current scenario, but generative AI was not that um, adapted because of many problems. So we were using conventional methods of modifying the data so that data augmentation can be done. So now we have done data collection, data pre-processing, then what kind of, you know? So this and training methodology. So first we define the problem. What is a problem? If you want to find out what type of pest is this, so it is a classification problem. If you want to find out whether crop yield will be below the threshold or above the threshold, that is also a classification problem. But if you want to exact find out crop yield, then that is a regression problem. You want to find out the numerical value of the crop yield. Or if you want to detect weeds, like you have to identify, okay, in this entire picture, here is weed, right? So that is another problem. That is known as object detection problem. So accordingly, we choose model. So it depends on model choosing requires data features. As I told you, that current AI model are not so good in processing all types of data uniformly. For speech data, you need different model. For image data, you need different models. For for say natural language processing, you need different models. And therefore, it depends on data features, availability and type of data labels. If suppose data labels are not done, then what will you do? You will apply clustering, right? If data labels were available, then you could apply a classification model. So uh, uh, now, if it is a temporal data like time series data, then in that case, the sequential like association between like semantics associate semantics is important. So for temporal data, you need to understand how the things are growing. Something is being like left out, something is carried further. So temporal data is something that requires a different uh, mindset for people to understand. Like even humans are sometimes not able to understand. If you ask me stock exchange key yesterday and 2 months, this was the stock exchange, I will not be able to do that because I am not an expert. So only those experts who have understood the patterns of stock exchange, that will do. But similarly, if you ask a farmer that last year this was the kind of pattern of rains and this, he will be able to tell you better that whether the crop yield will be good this year or not, right? So everybody is having a different type of understanding about temporal data. Uh, so we'll have different types of AI model. So today in this course of lectures, we will be telling you, we will be discussing with you different types of AI, right? Training also depends on the data characteristics and labeling. If the labels are available, then training will be done differently. If lot of data is available, then you need like uh, if see variety is available, then the child learns better. If we say, right, when somebody is learning in a village, he will learn differently. Somebody is learning in a metro, he will learn differently. But village child will be able to deal with difficulties much better than a metro city child, right? Because he has not dealt with ground truth, reality might not be. So training depends on the data characteristics and labeling. So we will be also learning different training strategies, right? Then comes, once training is done, model evaluation. Now, model evaluation is performed on unseen data. Like you create a autonomous vehicle, right, in a lab, then you run it in your laboratory around your lab. You're happy with that. So then you deploy it to a road, actually live road, right? Similarly, transformers are made which are within the lab, then they are tested within the lab, then they are tested in their own premises, then they are finally sent to deployment. So transformer is something which cannot be removed out of all of a sudden. Similarly, AI models, like if it is in a pacemaker of human, can it be removed? It cannot be. So we have to see that on unseen data, models should do very well. ChatGPT is doing very well on unseen data as well compared to others, but it has its own biases. Now, deployment depends on the type of application. It can be mobile application, it can be web-based application. So we will be telling you one web-based application, how to develop, then how do you deploy it on edge devices, how do you process data. Uh, Drone based, Akshay is good in drone based like data processing. So these are something. So we have done data collection. What are the sources from data pre-processing? All this we will be doing one after the other. Then model design and training. And then I would like to end up by telling you about the current state of AI applications in Indian agriculture. If I look at the World Economic Forum report, that is some maybe unbiased kind of report. Uh, so if you look at this, my dear friends, those who are from agriculture domain may be knowing better than us. Showing, not showing. Maybe I need to display. Why it is not showing that? Control, control. No, no, here it is showing, but there it is not showing. Can somebody help me? This. Yeah, yeah, that's good. Thank you. So AI for agriculture, how Indian farmers are harvesting innovation. You can see that at sporadic, like growth is there, but it is sporadic. It's not very like at a scale, but they have given inspiring story about, and I must say that south of India is more aggressive in this. So you can say Sagu Bagu project under AI for AI has enhanced yields and incomes for 7,000 chili farmers from Telangana, doubling their earnings through agri-tech and data management. So wide set of climate and economic challenges are there, but the impact of AI is there. Is there. So the World Economic Forum is telling about one. This Sagu Bagu was basically, sorry, Digital Green was a project. This was supported by Bill and Melinda Gates Foundation. So you can see that some interesting initiatives have been taken, right? So definitely it is an important thing uh, that these initiatives are taken, but we need to do it at a mass scale. And that is the reason I say that your uh, your contribution here is important. So I would like to also tell you about India in news, like Indian farming using AI. So BBC News. So you can see that about which she was talking. These are weather stations. I mean, our students, our teachers can do this. There's nothing. 50% fix. I go to the next slide where from Sunset TV also, Joint Secretary is telling something about the use of AI, but that is also in the south of India. So we can say that they are progressing fast. Skip. I don't know, it's not skipping. Sorry. I'm sorry, this is not skipping. That's just a bit. Don't do anything. You can sit. When I skip, it is stopping. Anyway, we are watching another application of AI. So anyway, this is the second. This was the second thing, news from Sunset TV. We get the official report that how a very simple farmer who is illiterate is able to check whether to irrigation to be done today, you have to do watering or not, and what is going to be the certain alerts are generated. All these things are done making use of AI. But when we say that these are encouraging applications, these applications are very, very small in size. So, so I will give you the links, so don't worry about this. So that is all from my side for today, for this part, because I just wanted to just give you a very like high level introduction of AI. Now we will be dwelling deep into the current AI, that is machine learning and then deep learning. So I will be focusing on machine learning, and then in the later sessions, we will be discussing about deep learning models. So we will be ready with your pen and paper. We'll be doing some machine learning, understanding what is machine learning, right? I'm sorry for this technical glitch that kept you waiting for some 12 minutes. And I hope that we will cover this up sometimes in
Hello. Hello.
Sir, we are not able to hear you. Can you repeat in short?
Hello.
Can you repeat what you taught in short, sir?
Hello. Am I audible now? Hello. Warm good
Yes.
afternoon to everyone. So thank you, Dr. Akshay Pandey sir, for giving me opportunity to share insights on the foundation of precision agriculture. So together we will travel how Indian journey will go from these different eras. So we were largely dependent on the traditional farming before 1915, as you can see here. So uh, we were mainly dependent on the animal power supported by the human power. After that, in 1951, the tractors and tube bells came into the picture. And however, it was not sufficient to meet the food production of the India to meet the growing population demand. So that's why we have shifted towards the green evolution. And after that, in 90s, 90 around, the various digital systems have been introduced, such as remote sensing, Kishan call centers, and many others. And after 2010, we have shifted towards the precision and smart farming era because there were various challenges that we have to address. And there were some key takeaways from each era that we will discuss later. So we can see that we have moved from the muscles power to data power from nowadays. And we can also say that every era solved each problem and created a new challenge. Also, each phase appeared to due to necessities such as food shortage, yield stagnation, and ecological stress. And now the precision agricultures come into the picture towards the sustainable agriculture, where we need to give right inputs at the right time with the right amount and the right location. So why we had to leave the traditional farm? Because there were some challenges like population growth, resource scarcity, food production has to increase to meet the increasing population demand. And there were some environmental impacts which came from the higher utilizations of fertilizers and chemicals. And there were some economic perspective in this era because the smaller marginal farmers cannot afford to buy the high cost of fertilizer and many other things. So this basically entails about Indian agriculture reality. So now we are feeding more than 140 crores people, and each year 1.5 crores people adds to this population. Also, the arable land where we can these lands can be used for the agriculture has been reduced from 0.3 to 0.12. Also, the we have the farmers; they have land holding capacities less than 2 hectares. They are around 86% of Indian farmers. Also, the climate impacts have been seen during the last few decades, like heat stress, irregular monsoon patterns. Just we have seen recently in Diwali here. So back in the 1950, we have agriculture shares around 50 to 59%, and the 70% of workforce were dependent on the agriculture sector. But on that time, the population is around 60 crores. And also the yields, whatever we are getting from the agriculture is less than 700 kg per hectare, which has been increased now to these 2600 kg per hectare. Also, the less than 20% of the cultivated area was irrigated, and the land was fragmented, as I mentioned earlier. And the economic reality reveals that the farmers were getting less price for the crop. These were the some traditional tools. Here you can see that the manual tools are there, and these were the traditional canals. Now we have the advanced canal system, also with the integration of the renewable energy like solar and many others. So why we have to move towards from the manual era to the digital era? So there is a need for green revolution because in the 1960 we were facing the droughts problems and the food scarcity and many other factors, and the farmers were not willing to go for the farming. So, so there were various schemes developed by the Indian government as well as the some scientists to provide the high yielding varieties which can yield more crops per hectare of land. Also, there were some system provided where we can irrigated the land, and the mechanization was taking place rapidly with the help of subsidies and other systems. Also, the institutional supports was there. The various agriculture university and various agriculture institutions supported this green revolution. So, without any leader, we cannot move towards the any revolution. So, these two were the main leaders who brought green revolution around the India and around the world. So, first one is the Dr. M.S. Swaminathan, who is known as the father of the Indian Green Revolution. And another one is the Dr. Norman E. Borlaug. He is known as the father of the global green revolution. Together, they worked for this green revolution in India. So there were some various achievements like the production has been increased from 15 million tons to 150 million tons, as well as the irrigation facilities have been expanded, mechanization boost, and rural prosperity were there because the farmers were getting the high income for their produce. The scientific infrastructure have also grown. However, it has created the some challenges. Like it spread the regional imbalance because the some states have got a great advantage from this green revolution, like Punjab, Haryana, and western part of Uttar Pradesh. But the rest of the states were negatively impacted, and also the we have a large farmers who who got the great advantage from this green revolution because they had the capacity to buy the fertilizers and many other things. But the small farmers often fell into the debt, and the groundwater was depleted because we were only focusing on the increasing the productivity, and this also affected the soil and environmental stress. And we also lost the crop diversity because largely the green evolution were focused on the wheat and paddy. So why the transition was needed? Because there were social economic pressure, resource stress, agriculture growth was declining. So these were the some reason drives which drives the green revolution. So after that, in the during the 90s, the government has taken the some initiated like remote sensing resolution by IIRS. After that, the GIS and database development came into the picture to access the crop health. Also, the for solving the problems of the farmers, they initiated the Kisan call centers, so farmers can get their problem resolved there. Also, the various mission have been launched like National Horticulture Mission, National Mission on Micro Irrigation, District Agriculture Metro Advisory to support the Indian agriculture system as well as the Indian farmers. After that, what was the impact of this era? So we can see that we have developed the crop diversification because with the help of digital tools, we accessed the soil health, crop health because that was the major advantage of the digital tools because we can see what is the need, what is the current need of the soil as well as the crop. And irrigation and productivity gains was there, and also the rural income and employment has been increased. However, the rural poverty dropped from 45% to 33%. In this era, we have launched the various programs such as the soil health card, where a farmer can go to the Kisan call center KVK, so that their soil can be tested and they can suggest like what will be the cropping pattern and what crops can be grown at your field, which will have a higher productivity and high market. Also, the precision technologies enter the fields like GPS-enabled tractors, drone for spraying and mapping, because the a lots of the chemical fertilizer were being wasted, because we have not accessed how much is required, how much amount of required by the soil and the crops. So here we can say that after the digital framework, the soil testing coverage have been increased from less than 10% districts to the more than 60% coverage area. Also, the agri startups in India, which was less than 100, now we have more than 2000 agri startup in India. Here we have Dehat as well in Jabalpur. And agri exports has just doubled from 1.8 to 3.1 lakh crore. So impact on farmers and road to precision agriculture covers the sustainability and climate action. So in 2016, United Nations has developed 17 sustainable development goals. So this precision agriculture era supported this sustainability, because we have to meet the environmental concern, economic concern, and as well as the socio-economic factors. The precision agriculture and the smart farming era include AI, smart mechanization, sustainability, and carbon focus, because the agriculture system can also support the carbon credits, which we have been talking about recently. Also, the economic impact have been boosted up to the 4.5 lakh crores. It includes the various things like from Internet of Things, computer vision, artificial intelligence, and integrated data platform to support and promote the agriculture systems. So there are some advantages from this era. So we have been able to save the resources like fertilizer and pesticides use cut down 20 to 40%, and we can save up to 50% water. Also, we can make the data driven decision because we have been receiving inputs continuously, and they are the higher profitability in systems like polyhouse. We can sell our crop like 80 rupees per kg for tomato even in the off season. And there were some environmental benefits like lower chemical runoff, improved soil health, reduced greenhouse gas emissions. Also, the inclusivity through the there are some organization have been introduced from the farmer side, so that they can raise their voice if they have some problems, so they can talk with the government, local authority, and the other industry. And also there were the skill development is also taking place like this workshop. So there are some key barriers which limit this use of the precision agriculture and obsession, because the whatever technologies they have like drone agricultures, and they have a very high cost like 10 lakhs to many crores. However, the income of the small farmers is very low, like less than 15,000 per month. And there is infrastructure gap because rural areas currently do not use a lots amount of technology. In the future we will have a good scenario, or there are the interoperability problems because we cannot assure which companies is providing a good quality of the sensors and many other things. And skill and awareness gap are there in the rural regions because the farmers are not well connected with the information which is providing by the government institution and many other things. And there are some issue with the data privacy and ownership. And also we have the fragmented land holdings which this restricts the use of the precision agriculture. Also, the access to credit and insurance. The normal farmers are scared to get loans and the insurance products from the government, just the lack of the awareness. And there are the climate uncertainty because we cannot predict the climate, when will be when we will be having rain and many other things. So this is all from my side. Now the lecture is handed over to Dr. Akshay Pandey. Thank you.
For this historical knowledge about the agriculture to the precision agriculture. So, can I ask one question like what you are getting from this presentation as a precision agriculture? Like, what is the actual requirement that we need to discuss about the precision agriculture? Yes. Yes, optimization of the resources. Another, and in his presentation, he shares he shared some barriers. Yes, so the barriers. So now we are here to work on these barriers by the collaboration of the insights which is giving from our expert and your contribution as well. So we will try to figure out these barriers can be removed, can be optimized, or can be resolved. Okay, so uh, as you already learned about the what is traditional agriculture, what we are doing with the agriculture in the previous era. So the word precision agriculture, that is the important word, the precision agriculture. So we are doing uh, that we already discussed about this problem. So the solution is the precision agriculture. Okay, like data driven decision with the help of the different language, technologies, methods, hardware, software. So that can be helpful for the precision agriculture solution. In this, you can see this is the core idea. This is a very important, or we can say it's a punchline for the precision agriculture. The right input. In the previous slide, we have the problem. Anybody, we are giving the water, anybody, we are giving the fertilization and all. Here we can see the right input at the right time, in the right amount, and the right place. This is the basic core idea about the precision agriculture. If we know about this idea, then we are in the era of the precision agriculture. Okay, so from this figure, you can see the above part, we have a different data-based tools. Okay, the remote sensing tools we have, IoT sensors we have, equipment telemetry, equipment entries, machine algorithm, climate, environmental, and historical data. So this data is we need to purchase somewhere, we need to acquire somewhere, we need to cover from UAV and different from the sensor. On the basis of this data, we applied some AI and ML techniques or deep learning, machine learning techniques on that collected data. And then with the help of automation, we are able to enhance the resource utilization, optimization of the resource, and we also able to identify the disease as earlier. Okay, so with the help of precision agriculture, the entire combined package from the data to technology to the resource optimization, this is a precision agriculture helpful. So why precision agriculture? As we know that the previous, like we have the challenges, overuse of the water and fertilizer, and without any prediction like how much amount of the particular crop we are getting in after the particular season. So the like unpredictable yield, climate variability. So to remove these challenges, we have to go with the precision agriculture. So this is the only solution when we are using a different parts of the precision agriculture. So we are able to increase the efficiency, optimize yield, pest and disease control, reduce environmental impact as well. So when we are talking about the precision agriculture, these are the basic backbone of the precision agriculture. We can say it's a backbone. If we are having these tools, then only the precision agriculture can be possible. So the satellite, you know about that. We have a multiple satellites. Yes, some are paid basis, some are open access. We can download the data directly. UAV or drones. So right now, many of NGOs, like I think you heard about there is a one government startup. It's a self-service group kind of startup, the Drone Didi. Okay, so they are doing this work. Why they are doing this work? Because you know, each and every farmer is not capable to purchase the drone, but they can hire some services with the help of government. Government will help you because this Drone Didi project is with the PMO initiative. Okay, so this kind of drone facility we can use, and soil and weather sensors we can put in our farm, and then we are getting the real-time data as well for the IoT edge devices calculations. real-time environmental data analysis, GPS and GIS system like global positioning system. If you want the accurate information about your farm, how much crop like wheat percentage in your entire your farm, how much sugarcane you have. So with the help of GPS, we can analyze and find out the which parcel is for sugarcane, which parcel is for wheat. So that is possible with the GPS locations, artificial intelligence, and the variable rate technologies. So that is a combined package of this variable rate technologies and the Internet of Things. So we have to follow the precision farming. So the first we require the data. Without data, can we do the precision farming? What do you think? No, it's very difficult. So first the data collection is important. So what resources we discussed about the data collection? Yes. So like the data can be available from the open source, or we can also ask somebody who is already worked in that particular domain, or we need to purchase also. So these kind of data collection we need to do. Then we have to analyze the data. What is your objective, and according to your objective you have to analyze the data, and then decision making. On the basis of you are making the decision and then implementing the variable rate applications, and finally you are monitoring in the entire evaluation of the precision agriculture. So as per this CAGR report from 2023 to 2033, if we are using the precision agriculture, our growth will reach what percentage? 12.2 percentage. Okay. So like we can see from this graph, if we are using the precision agriculture, the benefit will comes for the government, for the people, for the farmer. Okay. So these like basic stats from the agriculture world in the form of global agriculture world that we are getting. So the precision agriculture, what we are able to do, we are able to the sustainability, cost effectiveness, scalability. So these are the some resources that you need to, if you want, you can go with these resources. So if we are discussing about the precision agriculture, so what type of precision agriculture that we discuss? Satellite remote sensing in the form of agriculture studies. So we can calculate the vegetation index from the downloaded satellite imagery. We have to go with the UAV remote sensing with the same purpose, like we have to calculate the NDVI, GNDVI, SAVI. So these are the indexes can be calculated. Then the spectroradiometer. Spectroradiometer is a handheld device, okay, where we can get the direct spectral signature of the crop. Okay, there is no need to process the data. We are getting the finalized spectral curve of the particular data. Then vegetation studies for the smart farming, like we are using a smartphone, we are scanning the particular crop, and we are getting the insight. The crop is healthy, unhealthy, or there may be some disease. So on the basis of this processing, we are getting some fruitful input from the expert on the same device. And then WebGIS for vegetation studies. So now we are creating a virtual environment where farmers can visualize their own farm in their laptop, in their machine, with the help of internet only. So that is a WebGIS. Okay. So you can see this is a spectroradiometer. This is a multispectral megasense radar camera that we need to equip with the UAV. So we are able to capture the 5 band remote sensing data, the red, green, blue, NIR, and near infrared. And then this is the Landsat 8 satellite, which will provide you the freely available data. You can directly download the freely available data at 30-meter resolution. Okay. So then the Sentinel-2 data, it is also open source. We can direct download it from the USGS website. This is a DJI I used in my PhD work when I was in IIT Roorkee. And this is a quadcopter, this multispectral megasense camera equipped in the assembled drone. Okay, so we are getting the multispectral images from this camera. So UAV, like you can see that it's a remote based system. We can fly from 1 kilometer or 2 kilometer from our farm or field. So this is you can see in this image, there is a one pilot who is just using a remote and able to fly the UAV in their desired area of interest. Okay, so with the help of UAV, what you have knowledge about the UAV, what like UAV in the precision agriculture? Do you have any idea what UAV is doing for the precision agriculture? That is like we are able to collect the images. Okay, can we process the images as well at the same time, real time? On-board processing can be possible. So what like add-on we required to add on that particular UAV? Yes, you are very close to the answer. Like if you have a UAV, you have this you have this UAV, then I change this RGB camera to multispectral camera. Okay. Now you just want to, from this UAV, I am just collecting the data and then process in my system. Okay. I am asking if I want to process the data, UAV itself, and getting the result remotely. I am not just flying the UAV remotely. My thought process is I am flying the UAV remotely and getting the real-time result remotely as well. And we are taking the decision. So there is a one device that is called the Jetson Nano. I think most of you people know about the Jetson Nano. That will help to produce, because it will provide you the GPU environment. So you can process your images at the real time, or we can say it's a near real time. There may be some seconds or microsecond delay will be there. So with the help of UAV, we can do these things. So we can collect the data and process in their system. We can collect the data and process in the real time as well. Okay, so both things can be. Ma'am, there are two types of Jetson Nano. Ma'am, you are talking about Jetson Nano or UAV? Jetson Nano. So there are two types of Jetson Nano. If you are using a very basic system of Jetson Nano, like you have to capture the, or I used for the tree count. We are just counting the tree. So this is a 20,000. Okay, this is Jetson Nano. If we go with the Xavier, then it will cost 1 lakh. So both are able to done, but the thing is the processing time. Yes, so that's why I am saying it's a near real time. If we are using a 20,000 Jetson Nano, definitely there may be some delay. Okay, so from this, like we have three types of drone: the fixed wing, rotary wing, or hybrid. So this is the like how they are the overall flight time. If we are using a fixed wing, you are using a rotary wing, hybrid. We will discuss in detail, and also there are hands-on session to assemble a drone, fly drone. First we simulation, and then in the real time on the field. Okay, so this is just information what type of drones we are having. Okay, so the fixed wing, I think you know about the fixed wing. Most of the people came from the airport. Yes, they are using the fixed wing. Yes, then the rotary wing, maybe a multi-rotor. Okay, multi-rotary. And the hybrid, it's a combination of fixed and rotary. It's a VTOL, vertical takeoff landing. Okay, so VTOL, that means we have a both rotary wings as well as a fixed wing. Okay, so these are the different flight time, payload, how much payload we can take, and the maneuverability, the best use. So if we are dealing with the fixed wing, so large, we have to cover a large area, then we have to move with the fixed wing. If we are interested to the detailed inspection, like the surveillance, then we need to go with the rotary wing. This hybrid is still in the research for everyone. Like we are thinking about 200 kilometer in a one go. It is very difficult. That is possible with the hybrid, but still they are doing in the kind of research. Still we are waiting for the final results. So we are able to move 1 kilometer, 2 kilometer, 5 kilometer, 10 kilometer. After 10 kilometer, this hybrid is also impossible. Okay, so still we are doing in the process of precision agriculture, like we have a large area of farm, then what drones we require. Okay, so sub-sensor applications. So these are the different drones. The RGB, we are getting the RGB images. So in the RGB, we are able to classify the images. We are identifying the different crop area. Okay, Then thermal sensor. So thermal sensor, I think you know, when we have some like forest fire, okay, so that can be helpful. And then the multispectral, the crop stress assessment, vegetation assessment, different index calculations. Okay, so that can be possible with a multispectral camera. This is our multispectral camera. This is a Red Edge MicaSense multispectral camera. RGB normal DJI camera. This is our LiDAR camera. So LiDAR camera, it's just based on, I think you know about the LiDAR sensor. LiDAR sensors. If you want to measure the depth, what sensor you will use? If you want to work in a hilly area, if you want to work in a glacier, so these are the different camera that we can use as per the. So for the agriculture, we have to use LiDAR for the orchard tree height. We are able to measure the height of the tree. Okay. So these are the basic application of different sensor that we have. Yes, we can use, sir. It depends on the application, what application you want to use. So we have a one ultrasonic in my, so you can see, we will definitely give you the field visit and some drone accessibility. So we have RGB and ultrasonic and the night vision camera as well. So we will do it in the future. It means in 6 days future. So these are the some rules that we need to follow when you are flying a UAV. So these are the very important rules. But as you are a researcher, you are a student, that can be sensitized. Okay. So like we have to follow the DGCA, all you know, the DGCA rule we have to follow to fly a UAV in a particular area, like the red zone, green zone, yellow zone. So we can fly in the green zone only. Okay. If you want to fly in this red zone, you are in red zone. This IIITTM Jabalpur is a red zone as per the DGCA guideline. But we are flying here with the help of approval from the DGCA. Okay, because there is some army specials, airport as well, forest as well. So we have take the permission to fly our drone at 50-meter height for the training and research purpose. Okay, so they allowed as per the DGCA guideline. Then the FAA for the USA and ESA for the European states. So what we need to do about, first, if you are going to collect the data from the UAV, so the type certification. So when you are going to purchase a UAV, then you have to assure that the UAV is a type certified. Type certified, it means he is following all the guidelines to make a UAV. That is a type certification. Okay. So like in our vehicles, what we have BS4, BS5, they are following the guideline. Similarly, we have to file the type certification. And then we have pilot certificate, okay, as a drone pilot. So that we need to do some classes and then complete the course and then find out the drone certification, pilot certification. Then we have to register the drone in the DGCA, then drone pilot license. Before going to the fly, you have to check the weather, battery, connectivity. We have to check the satellite is available in the sky or not. So you, with the help of remote, you can check all the satellites are there. So minimum 7 satellites is required to fly UAV. Okay. So after this 2 parts, now you have to check the insurance of the UAV and the pilot as well. Okay. There may be some malfunction in the hardware. So your UAV may be damaged. So insurance will help you to recover the damage. And it is no permission for flying in a green zone. So you can fly directly in the green zone. When you are in the yellow and red zone, you have to take the approval from the DGCA. Then the another thing is satellite. So the satellite, like we already discussed some Landsat and Sentinel-2. So this is our satellite scanning our Earth and getting the data. Okay. So this is some Sentinel data set 2. It's an area from the Roorkee. It's agriculture land. It's a 10-meter resolution of Sentinel-2 data in 29 June 2019 when I was in PhD. So that is data downloaded from the USGS. It's a sample. So we have hyperspectral, multispectral, different satellite data we have. So when you have this type of Sentinel images, with the help of GIS software, we can process in the form of NDVI map. Okay, we are getting directly vegetation index map. And with this, so this is the Landsat data. This is the Landsat 8 satellite data. And this is the Sentinel-2 data. We calculated for the same area. This this is the raw images which is downloaded from the USGS website. And we are getting this NDVI map for Landsat and the Sentinel. So this is the raw images. Okay, Sentinel only. And this is a Sentinel map of that satellite image. Okay. This is a one spectroradiometer, is a handheld device. So here you can see we are directly getting the spectral signature. Okay, so we are getting the each EMR, we have a 700 nanometer, 400 to 700 we are a visible band, and then above the near infrared, ultraviolet. So we are getting here the direct spectral signature of that particular crop. Okay, so with this we can easily calculate the indexes and other features also. So this is a one software. There is no need the expertise. Just click next, 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 and you are getting the results. So this is a data collection using the spectroradiometer. So first we need to calibrate this sensor. Okay, so we are just calibrating the sensors. And after the calibration, we are in the field of this rise, and we are getting this spectral curve. Sorry, sir. This one, sir. Sir, this is a spectroradio. When we are capturing this crop, so we are getting the wavelength of the particular crop. Okay, so like it's a 200 to 450 nanometer. Okay, so this is a vegetation index we can use. Now, I think we already discussed about the AI, ML, and DL in the precision agriculture by the ma'am. So I'm not going to discuss this. But these are some applications. So with the help of AI, we can disease identification, detection, automated weed control system, livestock, predictive analysis, and drone assisted health surveillance as well. So these are the basic application with the AI. So the key models that you need to know, we will try to cover these models in this session, like the CNN, basic support vector machine, random forest. So these models will help you to find out the agriculture health related applications. So this is a basic like normalized difference vegetation index map. So with the help of, we are able to water stat, nutrient, paste, and growth variability. So this is a like what we can do with the NDVI. You can see we have to the time series analysis. So from the same field, we have the NDVI value is 0.3 on 23 May. Now in the 20 June, we have 0.3, means our crop health is still. Is there any change? No, constant. And now 23 June, what we have? 0.55. There may be some increase. So this can be, time series analysis can be possible with the satellite image by the help of NDVI calculation. This is a basic, like with the help of NDVI, we are getting some insight from the agriculture. So we can say it's a like a early disease, early damage we can assess. So this is another example. So like in the previous we discussed the NDVI. Here we are discussing the green NDVI. Okay, so the value of the green NDVI, NDRE normalized difference red age index, MSAVI modified soil adjusted vegetation index. So these are the different indexes. The heat map, after the calculation that we need to put, if you are publishing a paper, it will be good for you to produce some heat map on that paper. That will give you the some like fascinating paper like this. So this will help you. So you have to follow the symbology, like the north arrow, the symbology and all. You can see the time series analysis with the same area of interest. So you can see the February 12, February 22. So it's a Sentinel-2 data set images variability that we are getting. This is another one case studies. Like we are detecting the crop stress from 27 June to 2 July, 26 July, 26 August, and 10 September. This is a one portal. I think it's not working right now. So what we can do, if somebody is thinking that we are a GIS specialist, then we can do in the work of the precision agriculture domain. Yeah, it's very difficult. If there is a one person who is a computer science background and he don't know about the remote sensing, GIS, then it's very difficult to him. Yes or no? Because he already completed PhD in computer science. Now you have to go back to the learning of the basic of remote sensing and GIS. Yes? What do you think? Is a problem? It's a tedious. So there is a one solution that we can do some programming like with the help of JavaScript. Okay, with the help of JavaScript, we use the Google Earth Engine. Okay, if you are a computer science expert, there is no need to deep in the GIS and remote sensing. You just familiar with the GIS and remote sensing. What terms we need to do, what terms we need to identify for the agriculture health, that is enough. Then you just open your Google Earth Engine, okay, and type the program in the JavaScript. And most of the program is available on the internet by the GE. Okay, that is the first thing. Another thing is when you have to download the data, again, you have to learn how to download the data. Yes, after the data download, you have to go with the website, the USGS website, download the data, and then check the data is okay or not. Like there is maybe some cloud, then what you will do? You have to remove the cloud or you need to find out some alternate. Yes. So what we can do, there is no need to download the data in your system. You can directly fetch the data from the related satellite. If you are interested in Sentinel-2, you just write a command, you can able to fetch the data of the particular area. Yes, we can do precisely. If I am interested only this pixels, just load my area of interest on the Google Earth Engine and we are able to capture the data of this area without any GIS and remote sensing expertise. Okay, we will hands-on on this session, Google Earth Engine as well. Okay, so from this, I developed this WebGIS portal. Okay, so this I also hosted in my server. It is live now, so anyone can access the basic calculation, the index. So you just need to click and click and click, and you are getting the data. So it is open source. If you want to upload your area of interest, it means shape file. Okay, shape file, like we have a boundary of the particular area. We need to just upload that file on that particular portal. He will provide you the index information. Okay, and we will discuss about this. This is my web portal for satellite image analysis. Another one is for UAV data processing. Yes, if you are having a UAV, you are able to collect the data. Now you have to process the data. Yes, process the data again. We are not using the precision agriculture as a we need a wealth to use the precision agriculture. So what we have a solution, we developed a one WebGIS portal for the UAV processing. There is no need to download or purchase any UAV software. Okay, there is a one open drone map system with the integration of Python. We are able to develop our own server without downloading, without purchasing any software. We can do manually, we can do automatically, it is possible. Okay, so that we already developed this portal for this UAV image processing and health index calculator. So in this model that I developed for 12 index calculation with their graphs, with their insights, you can directly click on that, it will give you the entire information. So suppose when you are going to collect the data from the UAV, you will get some small images of a particular area. Then we need to combine this as an ortho photo. This is a complete ortho photo generated by the UAV. Okay. So this is basic about like what we are going to discuss in the continuous sessions when we are dealing with the precision agriculture. So what you will learn in this session, what is traditional farming that we are doing in the previous era, then the precision agriculture, different hardware, software, and the techniques. So in this 6-day journey, I will try to hands-on on each session, like remote sensing and GIS, Google Earth Engine, how to make your model with the help of Google Earth Engine, how to process the data online, okay, without any GIS and remote sensing knowledge. So that will be discussed in the like your entire session. Also, we will deal with the UAV assembly. So we have a one lab session where we have a different parts. You have to just go and check how to configure a UAV. Then simulation of a UAV. So time is one. So we have a one session with the simulation of UAV. Wait for a 5 minutes. I will continue. Simulation, sir, there is a air sim. So I just call them, so they will start. So any question so far from this, like traditional farming to precision agriculture? Yes, any questions? Just a minute, please. Ma'am, when you have a wavelength of a particular plant, we can optimize with the index calculation. Like we have a different index calculation like NDVI, SAVI. So we can just put a mathematical calculation on the basis of like we have a NDVI. So the total area of NDVI is -1 to +1. So if we are having a highest NDVI values, like we have a 0.8, 0.9 with the help of wavelength, it means our crop health is good. If we are getting a 0.1, 0.2, it means our crop health is decreasing. Yes, that we can do. No, only wavelength. If we are going to optimize the solution, yes, that we can do. Yes, so in the spectrometer, we are getting both RGB images as well as the spectral images. So that both we are getting. So you can see from the human eye as well, like what is the spectral curve and what is the actual image of that particular crop.
I have posted my question in the chat box.
Ma'am, if we are talking about the spectral, like we have a multispectral data. So multispectral data, it means we have, as per agriculture, we are using the NIR band, okay, more than the RGB. So we can calculate the different health index, okay. And when we have a hyperspectral, so the application like we have to go with the forest fire, okay, some like depth information, from the dense forest vegetation we have to identify. That can be possible with hyperspectral. Chetan Bhula.
It's not audible, sir. It's not audible. I posted my question in the chat box.
Session. Okay.
So चालू है सर. So basically, this is Clearview. It is a RC glider simulator. So basically, there are different planes also, and different platforms also. So on. Hello, hello, hello. Hello, hello. So basically, this is a simulator software for testing drones also and RC planes also. So currently, we are flying a RC plane. So basically, in RC planes, there are three movements. Like if this is a plane, this is roll, this is pitch, this is yaw. So there are three motions due to which the RC plane flies. So like if I'm doing this, so, oh, okay, okay. So basically, there are 8 channels in this. This is one channel. This is second channel. This is third channel. This is fourth channel. So these 4 channel. Apart from these are all switches. These are for payload drop and setting some different controls for the drone. So basic in this workshop we will only use these 8 channels. Okay, so this is for thrust. If you will which this if you will press this up, the thrust will be up, and if you will lower it, the thrust will be off. This is for left right movement, and this is for pitch up pitch down. If you will press it down, so the plane will pitch up like this. This is for left and right. Thrust. This is for left, for right. Same. This first one. So currently, sir, we are not using rudder, na? So, okay. This is the first channel. This is for thrust. By keeping the thrust up and this stick down, you can pitch up the plane. Okay, like I'm showing you. Okay, thrust up, pitch down, the plane will pitch up. Okay. So basically, this pitch up, pitch down is connected to the elevator of the RC plane. So if the elevator will go down, the plane will experience upward force, and so the plane will pitch up. Okay. And for this, yeah, thrust plus this pitch down. Okay, so for the third channel, the third channel is connected to the ailerons of the RC glider. So what is the left and right motion of the RC plane is controlled by the ailerons of the drone. Sorry, RC plane. If I have to turn left or right, I will adjust the ailerons of the RC plane, so it will move left or right accordingly, like you can see. I am just using this left or right channel. Remote control. There's a receiver in that plane, and this is the transmitter for. If someone wants to try. Right. Acha, okay. Okay. So you know all the controls, huh? Okay. This is for motor thrust. Okay. This is 50% throttle. This is full throttle. Okay. And this is for left and right. Okay. And this is for if you will put it down, na, the plane will pitch up. Okay. Look, it's reverse. If you will put it down, the plane will pitch. And with this, if you want to for left and right, if you will put this left to, the plane will go to left. Okay. For initial, good. Right, right. Like while you are pitching up, na, it's too sensitive. You are going like this. Just keep it straight. And then if you want to go left and right, na, then go to left and right. Initially keep it this. अब आपकी दिक्कत क्या हो रही है? आप जब पिच अप कर रहे हैं ना, तो स्टिक थोड़ी लेफ्ट या राइट हो जा रही है। तो इसके लिए आप ऐसे पकड़िए, लाइक दिस।
Good afternoon. It's okay. Am I audible? No. Good afternoon. I'm Rajendra Vyas. I'm pursuing my post graduation final semester from Takshila College of Engineering and in energy technology. And basically, I'm an insurance consultant with HDFC Ergo General Insurance at Jabalpur. And I just want to enhance my future prospects. Thank you. Thank you.
Good afternoon to all. I am Dr. Himanshu Panjia. I am associated with Jimma University, Ethiopia. I am having expertise in AI for material processing as well as AI and ML use for water resource management. And I'm expecting here to know what other adventures of AI is left, and one of the important sector is agriculture. Thank you.
Good afternoon, everybody. Myself, Dr. Renu Pathak. I have been posted as the Chief Technical Officer in Krishi Vigyan Kent Dindori, and 18 years has been over here. And before that, I was been working as a head of department in DNGN College, Jabalpur, as well as 10 years I have served as a guest faculty in MSc and MCA department. And as Aparajita Ojha ma'am, she is my teacher, mentor, as well as she has given me the opportunity to serve there for 10 years as a guest faculty also. And I'm here with lot of queries, lot of questioning, because as I am working in the tribal area, sir, there the main feature is to how we can enhance the crop yield. That is my main motto. How we can predict crop yield with the help of this ML techniques. Lot of algorithms are there. So I want to develop a model so that my model can predict this crop yield. And second, how we can enhance. In that case, also various factors matter, as we are having automatic weather station also where we can collect a live data of the weathers also. Also, we are having mini labs where we are detecting 12 parameters of the soil in our Vigyan Kendra. So that also we are having a lot of data. We can work it. But actually, basically, I'm a computer background. So I want this to be done and enhance and benefit the farmers. Thank you so much.
Thank you for your, please, ma'am. Good afternoon.
Audible. Good afternoon. I am Sunitha from Kerala. Actually, I am from computer science background, and literally I have no connection with agriculture. But my father was a farmer, so I am interested in farming. Uh, so I wanted to know how I can connect AI to agriculture. For example, my mom is doing some cultivation at home, and when she is getting some disease with the cultivations, she is confused. Okay, what is the problem with this one? Whether it is because of the fertilizer or whether because of any pest. So I thought how we can help this kind of people with the help of AI. Okay, whether AI can help these people to do the fertilization or to choose the pesticides. Okay, so that's what I am looking from this FDP. Can the common people uh, will be benefited from this? Okay, thank you.
Thank you, ma'am. And I think we will try to figure out of what you are saying here. And definitely we will do like every man who is not having an agriculture background, they are having a traditional agriculture background. We will definitely revolutionize like AI in precision agriculture. Okay, please, ma'am.
No, no. Yeah, my name is Gina. I'm a professor in Githam University, Bangalore. We have a smart agriculture lab and different other labs like drone lab, geospatial lab, so soil analysis lab. Likewise, different labs are available. So in smart agriculture lab, we 8 members are there. Our coming for this this particular FDPS to get more collaborative works. We want to find identify some people who are very much interested in agriculture. In our lab, we are doing certain works related to disease identification, nutrient deficiency detection, soil analysis, and some post-harvest technologies. And some of our faculty members are doing very good in that aspects. So that's here. We hope we'll be getting some collaborative works with some universities and some GKVK or some foreign collaborations. That's our uh, ask from this particular.
Good afternoon to one and all. I am Dr. Rajesh Kumar Sahu. I am Professor Agriculture Extension at Indira Gandhi Krishi Vishwavidyalaya, Raipur. Presently, I am posted at BTC College of Agriculture and Research Station, Bilaspur. As I am already professor, तो in our group वैसे अब तो बाबा हो गया, बना आगे जाने का कुछ है ना पीछे जाने का कुछ है. So I am here just to learn because I have a long time to retire and to balance that all from the computer side are here, AI, and I am from agriculture to balance the precision in the AI in precision agriculture. So just to learn about what are the basic things evolving and how they are coming for the future and how to pick up them to deliver them to the farmers. And one expectation is also that as I am layman in the field of your side, so maybe the coding and other things are there as per your program schedule. It may be as per that we can also catch up from there. Thanks.
Okay, so good afternoon. I hope you enjoyed your lunch. You will introduce. They already know. Okay. On 41 years of my teaching and research. Thank you. Thank you for your kind words. Definitely, I'm senior most. My gray hair are telling that. Anyway, so I hurriedly gave you introduction to AI. What is the AI pipeline? How do we process um, data and train model for developing AI application? So now we will be talking about machine learning. More like I will not go into deep learning details because time does not permit that, but I'll try my best to give you an introduction to machine learning. Those who are not from the field, because this is a heterogeneous audience, so we have kept it the level. Yeah, this is what like is happening. So this recall that we talked about this, and deep learning started its showing its strength somewhere around 2012 when the first LXNet model uh, won the challenge of large scale image recognition system with 1.4 million images and 1000 object classes. So that was the success story. Like from there it started, and then slowly in 2014 also, 2014-15, several developments took place, including generative models known as generative adversarial network. And then one more important part, that is how to train a very deep network. Like we have tens of thousands of neurons. How do we train very deep networks with 152 layers? So it was a Facebook researcher, Kaiming He and his co-workers, who showed the way of making a deep neural network learn with so many layers, huge set of layers. So problem of what is known as vanishing gradient problem, that was solved because people could, like what happens that when you are, we will see that when you are training a model, you need to update the model on the error it is making. So that updation was not getting done. That is known as vanishing gradient problem in crude sense. And deep learning took place, like we came to know alternative methods of training neural network. Then moving forward with deep convolutional, generative adversarial network, in the idea of diffusion models in image and video processing, and models like ChatGPT for language processing. So two very important developments took in the current decade with 2020 diffusion model for image and vision engineering, and for speech and natural language processing, ChatGPT and Llama and many more. So large language model to be generic. So, so a simple way to think about AI is as a series of nested or derivative concepts that have emerged over more than 70 years. So these are, we can say that AI is a big branch within which machine learning is a sub branch of that. Deep learning is a method which tells how to understand how mind represents knowledge, like how the representation of data is stored. Like if you meet someone after 20 years, 50 years, 30 years, you may be meeting and maybe, so you will know him through, you will recognize him through face, even if the face is changed, like I met her. So even if the face is changed, you know that this fellow is known to me for for long years. So what is represented, like despite all the details a human body has, people only remember through face and specific points, features of face. That you remember that. So that is the knowledge representation or data representation, to be precise. So deep learning models were good at data representation capability. That helped a lot. So if I ask you what is machine learning, if I look at the farmer's learning, because it is, machine learning is human learning, human intelligence based. AI is basically mimicking of human intelligence. So yesterday I created this using Claude. So suppose I look at the farmer's learning. Farmer learning, step one, they actually observe patterns like early rainfall or high soil moisture, right? And then result it found, observed that it was good yield. So you can say that the farmer said that I noticed this pattern year after year. If there is an early rainfall and high soil moisture, then at least kharif ki fasal achhi ho jayegi, right? So learn from experience. Second, step two, over many seasons, patterns become clear to the new farmer, right? Many new farmers are now making their career in this field, agriculture. And then farmer builds mental model that I understand what leads to good yield and what leads to a poor yield, right? And then becomes predictions. If I see similar conditions again and again, I will expect similar results, right? So that is, experience helps me predict the future. So I observe the pattern, I understand the pattern, and I am able to predict making use of experience on data. Exactly the same thing happens in machine learning. So machine learning is like we collect data as farmer observes pattern without collecting data, but it observes pattern. We need to collect data. And so computer receives historical farm data. Then algorithm finds patterns in data. Just like farmer finds patterns become clear. Then we build a mathematical model, although it is approximation model, but we call it mathematical model. So ML learns what leads to good yields. And finally, given new weather condition, the machine learning model is expected to predict what will be the crop yield over a period of time, right? So this is how between machine learning, normal machine learning, and then normal behavior of a farmer, human. So we are basically mimicking the learning, human learning with a by a machine. So in a way, we can say that machine learning is a field of computer science that gives computers the ability to automatically learn. We don't tell the rules that if it is equally blue and green color, then it becomes yellow. We don't tell that, right? There's no rule that we are telling, but it is observing the pattern. Just like I keep telling my students that if you give 3-4 instances of, say, yellow color objects to a child, it will automatically learn to understand yellow color and will distinguish between yellow and green, right? It will be able to do that. So even if yellow is in different shades, the child understands that. So different variety also, the child understands. So it is automatically learning without being explicitly programmed. So learning from experience on data, which is important, my dear students. Some students I can see here, right? So learning from experience on data to make predictions. You learn by watching others how to ride a cycle. Nobody teaches you. You learn as a kid, you learn how to speak. Nobody teaches us. I mean, some words our parents tell, ma, baba, right? These are common words, but we learn to connect words and speak sentences. So learning from experience on data to make predictions. So let us look at the, I discussed with you that we have data. So suppose we have some training data and let us assume that the data is labeled. Now you must be thinking, those who are not from computer science background, what is meant by label of data? So when I say I have a leaf image and I label it that this image is healthy, and I have another leaf image, I give the label that this is having disease, right? So I'm labeling it into two categories. So when I say healthy, disease, so this healthy and disease is a letter, like it's a word, which we convert into digital form, like 0 or 1, yes or no, right? So similarly, if it is a multi-class, then so let us assume that we have data, right? This training data is, suppose we have say 100 samples. Wait a minute. Actually, this full slide is not coming, maybe. Oh, sorry. I'm sorry. This I should do from here. Okay. Let me first explain. So suppose we have 100 instances of data, and then what we will do, as I told you, that some questions we keep for the final exam from our students, we don't tell them. And some questions we are telling in discussing in classes. So 80% of the data we are keeping for training. And suppose I'm saying that suppose 20% of data I am keeping for testing them, right? So this is divided into 80-20. And then this data is passed one by one to the algorithm. And algorithm is what? Algorithm is to understand the patterns of the data, right? And based on the patterns, it will be predicting, for example, leaf image is healthy, or it is unhealthy, or having disease. So it makes prediction, decisions, or any recommendation. Then once this training is over, now how this is done? Sorry, but so how this is done? Suppose we have 100 samples here. Oh, it's very difficult to do it here. It's not working. Anyway, so I'm sorry. I thought that I'll be able to use the pen here, but somehow it is. Now it is working. So what happens is that you have, so we have 100 samples here, right? So these 100 samples are split into, say, 80 and 20, right? I'm giving this in one go to the machine learning algorithm, right? And then it is predicting, so healthy or unhealthy. So suppose this is able to predict about, say, 56 samples, it is able to predict correctly. and rest of the samples it is not correcting, predicting. Let me take 56% rather than 56. Suppose 56% of times it is correctly predicting, rest of the time it is not, right? So I will be presenting again, just like if suppose a student is unable to understand, we present them the same similar examples. So we will be presenting again. And then this time we will be also presenting along with this that it has made some errors, where it is making errors. So it will be looking at those errors and it will be improving its performance in understanding the pattern. And next time maybe it is giving me 59%. This keeps on happening. This, like, unlike in human brains, which are very good at grasping quickly, machine learning models require thousands of epochs. So this is known as an epoch, right? These 80 examples are presented again and again. And suppose after 50 epochs, right? After 50 epochs, it is able to give you, say, 98% accuracy, right? So once it is done, we will be checking how much, what is the level of accuracy on these 20 samples. So this can be, say, somewhere around 97%, and we will be happy. But what I told you was that only after epochs this is done. That's not correct. Actually, what happens that after every epoch, we check what is the training data accuracy and what is the accuracy for this data, right? So after every epoch, we keep on again presenting the same examples which they have not seen. Like suppose think of a student who has not passed the exam. Again and again, we give them the same kind of data samples so that it is able to learn better. Now, so it has passed the exam now, it's 97%. Now comes the real data, which is coming from when the model is deployed. So new data samples come. So 20 more images of healthy and diseased plants are given. On this also, if it is giving some, say, 96 to 98% accuracy, then my model is trained well. Otherwise, my model is not trained well. So on real data, it should be on unseen, completely unseen. Why I said this is known as a validation data, right? This is known as real test data, which is never used during training. This is used in training because after every epoch, I'm showing it both training data as well as validation data, and this is known as training data. So once this validation error is, or validation accuracy is high or error is low, then only I will be coming back to this. So now I go back to the folder. What to do? Just a minute. Because of it is actually being telecast, right? So that is why it is creating a little trouble for me. I'll have to, okay. Last paper, yeah. Home, yeah. Yeah. No, my view board is acha. Okay, let me try what you're saying. No, it's not like that. It's like, oh, I'm sorry. Still, yeah. So I hope you see that this train model is deployed and now totally unseen real world data comes and then predictions are made. So if this prediction level, the performance here is the same as, almost same as the performance here. Like doctors, when they learn, they are learning under the supervision of their mentors. But when they go to the real world, they may be making, say, some 99% accurate diagnosis, but 1 or 2% they can be wrong in their diagnosis. So let us training. What is training? You have data sample, you have universal set from where samples are coming, right? Universal set means the entire world from where data can be gathered. For example, if I want to find out in Jabalpur city, if there are in maize crop, are there, what kind of diseases are there? I will, for me, Jabalpur is the universal set, right? So universal set, the data samples are coming. I will not be able to do all this, like from each farm. I am not gathering the data, but I'm gathering, say, data from a small number of farms. Then the machine learning model observes the data, learns from experience on the data, and then it makes prediction that these are of category 1, these are of category 2. Maybe malnutrition, these are highly nutrition. So training is learning to understand patterns for making prediction. That is what is known as training. Now prediction can be prediction of what? It can be prediction of, say, weather tomorrow. It can be prediction of category of the disease. It can be anything, right? So, so training is the process of making the system able to learn the patterns. Now in the testing, what happens? The same thing happens, but now no training data. The model is deployed in the in the real world scenario. Some test data comes and then it is fed to this. Now the model has already learned. It is observing data, not learning. This learning from experience is gone, and then it makes prediction, right? So this part is gone. So evaluation on its prediction on unseen data is known as testing. So training and testing are two different aspects which are very much used in machine learning algorithms. Any problem that you're facing? Yeah. मुझे actually वो just like when you are doing through a prayer, right? You don't want many people to disturb or be present, and that is, I'm sorry if I was a little rude on telling them go away. So it's like, for me, it's like another, just like a prayer. So now, क्या म्यूजिक बजा रहा है अभी? हो गया? Done? Huh? I don't think YouTube will be a good idea. Don't do YouTube. क्योंकि हाँ? Zoom is okay, but हाँ, क्योंकि वो उससे मेरा मूवमेंट है ना, किसी का भी होगा, राइट? अब ये आगे नहीं बढ़ रहा है. अच्छा, नहीं, it's not going further. What's happening? क्या कर दिया तुमने? Nothing is coming. See, lot of convenience. These technologies bringing lot of inconvenience also. Isn't it? We were happy without any mobiles, you know. Now anybody can call you at 12 midnight, 4 p.m., 4 a.m. You're lecturing, you are eating. So that is what. So technology is having a lot of, अब कुछ हो ही नहीं रहा आगे. I'm sorry. Yeah, now it is coming. Now it is coming. अरे तुम कर रहे हो, उधर से आ रहा है, यहाँ से नहीं आ रहा है. इसको देखो. No, it's not happening. Just check. Get a different one, right? No, it's not coming. Okay, so while they're doing it, so what is a machine learning algorithm? Let us understand. So machine learning algorithm is basically an algorithm. I hope all of you know understand what is an algorithm, step-by-step process to extract patterns from data, right? So what is learning here? I say that a computer program is set to, हाँ पता नहीं क्या हो रहा है इसमें कुछ, okay, is set to learn from experience E. Set to learn from experience E. That is the reason we did not want anybody to join online. But there was some special request initially, so we allowed. is said to learn from experience E with respect to some class of task T. So experience E means on data, right? Class of task T means it can be categorization, it can be finding the value, or it can be clustering. So with some class of task T and performance measure P. So for example, I told accuracy, it can be precision, it can be clustering performance, how close are the clusters, intra-cluster, right? Some class with performance measure P, if its performance at task in T as measured by P improves with experience C. What does that mean? It means that by showing the same examples for the same task, if the model improves its performance, then the machine has learned. You agree with me? But what kind of experience? Say, experience can be just showing the data. Experience can be data plus label. Or experience can be just some data with label and lot of data without label, right? Doctors are not available to label each data sample. They may be available randomly selecting some 5-10 data samples. And so that can be there. So some kind of experience, right? So now, is this working? Just check कि ये so these AI algorithms also learn at the face of uncertainty like we are having here, the problems that we are facing. अभी जो तुमने किया वो क्या किया? पहले ठीक चल रहा था. स्क्रीन तो अभी भी पहले भी शेयर किया था मैंने. था शेयर था. Zoom में शेयर था. Just give me a minute. क्यों नहीं कुछ दिखाता है? Bring my laptop. दुर्गेश मेरा लैपटॉप लेके आ. चार्जर भी ले आना, क्या पता है कि नहीं. So what happens is, now let me, what kind of experience can be there, or इसमें वही नहीं दिखा रहा है, माउस ही नहीं दिखा रहा है. अभी दिखा. अभी क्या करके गया कि अभी अच्छा खासा चल रहा था. इट वाज लाइव तो हटा दो कम से कम. लाइव नहीं है.